Thank you for having me again. I was here a little bit in December for the reInvent recap. And today I want to talk about something that is closer to what I really like. I'm really passionate about serverless technologies. As a developer, I always found that it was too complex to build things that supposedly should be simple. And last year, one of the areas where I felt talking with customers that it was probably not so easy, or it was not so easy to build a serverless application was real time. So beginning of this year, also because we launched some new features at reInvent, I said, let's build something. And the idea of this presentation is to tell you how I came out to build what I called a positive chat. So what is a serverless real-time application? It's an application that is using a technology that is called WebSockets. So WebSockets this is the definition of WebSockets from the working group, is a protocol that allows for bidirectional communication between a client that can run some untrusted code. And probably when I say untrusted code, everybody is already thinking about JavaScript. Sorry. No, but the idea is you really need to have code running in a controlled environment. So it's running JavaScript inside a browser. This is the most common use case. And you have a remote host that is the server supporting the WebSocket protocol that will accept this bidirectional communication. So why we need all this complexity? Because normally the HTTP protocol is a client-server protocol. So what happens is that the client, your browser, your mobile browser, is asking the server for something. Normally it's a GET to say, hey, give me this page, give me this image, and you get a response. This works very well, but if you want to build an interactive application, the only one that can start the conversation is the client. So normally lots of applications over the year implemented what is usually called long polling. So they ask for if something new is happening to the server with some specific URL. And if nothing is happening, they stand there with waiting for an answer. This is the long polling part. And then if there is something happening, the server is sending an answer, like, hey, you have a new message, you have something that I want to update about. And after normally 60 seconds, that's normally the maximum time you would do for a normal long polling. The session is closed, and the client will start asking again, hey, something new has happened. There is this very complex and infinite loop of long polling. 60 seconds is normally the time you use because this conversation actually can cross the internet and multiple proxies, so you don't want to get timeouts. So normally 60 seconds is a time that works well. If you do 5 minutes, probably you will find some timeout, and long polling would not work. So with WebSockets, things get a little bit more interesting, because starting from HTTP, the client will create a request to the server that is a connection upgrade. Is the fourth line there. Is telling, hey, I want to upgrade this client-server HTTP connection into a WebSocket. And the server normally, if it's polite, will accept the upgrade and say, OK, yeah, let's upgrade this connection. And then they will create a bidirectional WebSocket that behaves very similar to a traditional TCP socket. It's just a raw connection where you can send bytes. So the client can send information to the server can, at any point in time, send information back to the client. It's very well integrated with JavaScript, so it's easy to use on the client. And there are multiple implementations also for servers. So in this way, we can create this connection, and our application can receive notification. So actually, you could do similar things with serverless last year using some tools. So for example, AWS IoT. Has anybody here used AWS IoT? So you know you can use AWS IoT without any physical device, just for the sake of it. And AWS IoT will give you the possibility to use WebSockets with MQTT inside. So MQTT is a pub-sub protocol where you have like a hierarchy of topics. And what happens is that the client can send information to a topic, the server can receive this information, and you can exchange bidirectional information. So it's not plain WebSockets, because inside you use MQTT, but it works very well. For example, we have an open source framework that is called Amplify, that is normally for front-end JavaScript developers. And if you use Amplify, you have a pub-sub library that is actually built on top of AWS IoT, and it's designed to be pluggable so that if you want, you can use a different technology. 2 years ago, we also launched AppSync. It's targeting more mobile developers, but also web developers. It's very well integrated with native mobile frameworks and languages like iOS, Android, but also with hybrid development tools like React, for example. And with AppSync, you use normally GraphQL to ask for and update your data. And GraphQL has the concept of subscription. So if you use AppSync, you can say, hey, let's say that your application has the concept of an order. I want to subscribe so that if there is a change, what is normally called a mutation to this order, I want to receive a real-time notification. So with AppSync, you can create this client-side subscription that will be notified if something is happening in the backend. So still was a little bit complex. Last year at re:Invent, we pre-announced, and then we made it available, I think, in the middle of December, like sort of Christmas gift for someone, WebSocket support in the Amazon API gateway. And this is, I would say, a little bit more low level. It's really providing you access to WebSockets for serverless applications. So how does it work? So let's say this is my web browser, and this is the Amazon API gateway. First of all, this is a regional WebSocket API only. So with the API gateway, you can create edge-optimized or private APIs that can span across the region, so using the edge location or inside a VPC. WebSockets, for now, only work at regional level. That's why I put the region there. So the browser can open a connection with the API gateway. And this is a normal WebSocket connection, similar to what I showed before. And this is a stateful connection that is managed by the API gateway. What we assign to this connection is a connection ID that is used to recognize this connection. Then the Amazon API gateway, when it receives some message here, can forward this to a backend. So the API gateway can talk to traditional web applications, to application running inside a VPC, or a very common use case is to just integrate Lambda functions. So in this case, the API gateway can call a Lambda function and will pass in the event that you pass to that you use to invoke the Lambda function, the payload here and the connection ID. So this connection ID sent me this information, and it can send different events. So it can talk and invoke the function when there is a new connection. This is the connect event. So a new connection has been established. A connection has been disconnected. You shouldn't trust these connection events too much, because this works only if there is an explicit disconnection from the client. Lots of the time, disconnection happens because there is no network, for example. So in that case, you don't get an explicit disconnection. I will show you how to manage those. Or you can create routes using some information inside your message. Normally, you use a JSON syntax for your message. And inside JSON, you can use any path inside your JSON document to say, depending on the value in this field of my JSON document, send this to a different function in the backend. And you can also set a default function so that if there is no root information, everything will be sent to these default functions. So I will show how this route key works in a minute. Those functions can send information back to the client doing an HTTP post, an HTTPS post, that must be signed using the traditional AWS API signature, so with the secret access ID and secret ID. And it must specify the connection ID so that knowing the connection ID, the Amazon API gateway can send the information back. In this way, you can create bidirectional communication, and the Lambda function are triggered, do some processing, and then send information back. As you can see, this is a stateful connection. Here, there is no stateful connection. There is the connection ID that is used in each invocation to understand to which connection this event was related to. But it's very efficient from a serverless perspective, because if you have a client sending few messages, you don't need to have the Lambda function always running. They will only be invoked when there is actual payload sent from the client. So I was thinking, OK, there is this cool technology. What can I build? Now, normally, if you search everywhere, any tutorial with WebSockets, the mandatory example is to build a chat. apparently is like the hello world for WebSockets. And I say, OK, that chat is nice. I always like to build chat that I can use, because sometimes when I do workshops, I like to have some shared space where everybody can go and comment and publish things. But I was thinking, can I do something that can also be useful, not just another demo? And one thing that it's been really interesting to me over the years is communication. So it's part of my job as an evangelist to understand how to better communicate. And what I found is that lots of people, when they communicate online, they struggle. You see lots of fights on Twitter or fights even on chats. And I think the reason is because as humans, we developed to do face-to-face communication. We are not good in doing something that is purely textual. Because when you talk face-to-face with someone, you see the expression of the other person. You understand if he's joking or not. Even when you just use the voice, you can still understand the tone of the voice. But when you write something on a chat, it's very difficult to understand how your message can be interpreted by other people. So I say, let's try to do something that can improve the way we communicate in a chat. And how can I do that? Maybe I can use some AI machine learning service. Those are very easy to use. Actually, this is the machine learning platform in AWS after re:Invent. There's lots of stuff underneath for providing infrastructure, the tools, and the open source frameworks that we support, like PyTorch, TensorFlow, platform services that developers can use to create complex machine learning models. But up to the top, there is this nice application service layer that is super easy to use. There are already trained models that you can use. For example, with Lex, you can build conversations. With Polly, you can render voice, so create audio file that speak. It's the same engine that is used by Alexa, but with Polly, you can talk in lots of different languages. Recognition can analyze images and video. Transcribe can be used to transcribe an audio file into a text file. And just before re:Invent, we also launched the possibility to use this in real time. So you can create an HTTP2 connection and then send audio file. And in real time, you get the transcription of what you're sending. Translate can translate across multiple languages. And I thought this can also be interesting for a chat, because sometimes misunderstanding can just come by the fact that I'm Italian, and when I write something in English or in another language, I may misuse some word and create a friction where there shouldn't be at all. Comprehend is another tool that I thought it could be useful, because it can analyze text, do things like sentiment analysis. So for example, one thing I can do is to check the sentiment of what you write in a chat. And if you write something too negative, instead of publishing this to everybody, I can just tell you, hey, can you find a better way to phrase this? Maybe it can be more useful to send the message to the chat. Comprehend can also analyze the entities of a sentence, like I'm speaking about music, I'm speaking about AWS. So it can provide other information that can be useful. And then there's other services that I'm not using, like forecast to do real-time time series forecasting, or personalized for doing recommendations. So those are the tools that are very easy to plug into a Lambda function. So what can the positive chat do? So first of all, I want to avoid negative sentiment. So I want to reject anything that is posted that is too negative. And maybe I can do some gamification around positive sentiment. So if each person writing in a chat has a sort of a score that tells how positive and how negative is his posting, maybe you bring people to write and rephrase things in a nicer way. So usually gamification works better than rejecting. Translation, as I said, so maybe I want to listen to the chat, but I want everything translated to French or Spanish. And also extracting the topics, the entities that are used in a chat room conversation to improve searchability and discoverability. So for example, one idea, so this part is still not implemented, but an idea is that if I get the tags, so what are the topics that, so in this chat we're talking about AWS and serverless, for example, in this other chat we're talking about music and Pink Floyd. I can create a sort of a tag cloud. Maybe you saw those online where you say, okay, in this chat room you can expect those are the topics that will be discussed. And I can update the tag cloud almost in real time, so that people that wants to speak here knows what's the topic that they're talking about in that time. And you can also search or filter messages by tag. So these are all features that are relatively easy to implement. And that's what I built. So I use the Amazon API Gateway, as I said before. I have a web application, a very basic, simple web application that is stored on an S3 bucket. So there is some HTML, some JavaScript. There's actually no CSS, so it's really ugly to see. But I think I wanted to create something that is easy to understand and not nice to see for now. So the browser running on desktop or mobile will connect to the S3 bucket, download the static asset, run the JavaScript here that will create the WebSocket connection to the API gateway. And then I can use a Lambda function to filter all the discussion here, so all the users that are connected here, different rooms. And the messages that are exchanged here can be analyzed using Amazon Comprehend and translated using Amazon Translate. And I can use also DynamoDB as a database to store the connections. Because as I said, here you have a connection ID. So you normally need to have a table that relates the connection ID to an actual user, because a user can disconnect and reconnect and will have a different connection ID. And I can also store the conversations so that if I connect to a chat room, I can download like the last few messages to understand the conversation. So two things that are still missing that I want to build is authentication using Amazon Cognito. It shouldn't be complex. For now, you just tell who you are by user ID, and there's no check on that. And I want to analyze, as I said, topics. So I want to store for each table, for each room, chat room, some metadata. Like in this chat room, we're talking about, as I said before, AWS. In this, we're talking about music. Here I can also store, I was thinking of statistics of overall sentiment. So maybe if there is a chat room that at some point starts to have a negative sentiment that is growing over time, you can know that before joining the chat room, and maybe you can create a new chat room on that topic and say, oh, let's not chat in that area. It's becoming a little bit too noisy. So let's see how I built this. So first of all, let's go on the application. So this usually zooms very nicely. Can you see the text at the bottom of the room like this? App and web. OK. So as I said before, there are two components here. There is the web application running in the browser, and there is the backend application running on Lambda, DynamoDB, and the API gateway. So let's start with the web application. There is a very empty HTML here where I have a chat. So div in HTML is used to create a separate area. And then you can use JavaScript to change the content here. So I created a chat space here where I will post the messages. And then I have a control space where you have just a button and a text area where you can write something and post the message. So very, very bare bones. And then I incorporate this index.js script here. And this is a little bit more complex. So here I have the WebSocket endpoint from the API gateway. And this normally WebSocket URL have WS or WSS. So the double S means that this is a secure WebSocket connection. It's encrypted like HTTPS. Those are the languages that I support for now, because those are the languages that are supported for sentiment analysis by Comprehend. Technically, it's very easy to extend to more languages, because I can translate lots of languages into English and then do the sentiment analysis in English, for example. I just was lazy at that point, but for now, it's already lots of the people. Who's not in this? Who's speaking languages that is not in this list here? OK. So my target of being inclusive has already failed. Default language is English. Makes sense, I think, especially since we're doing this first in London. So just to have a quick look here, what I'm doing is I'm looking if there is in the URL a user, a room, and a language. So I want to know which is the user ID, which is the chat room you want to chat in, and what's the language you want to receive the messages translated to. So I want to have English or Italian or French. So if all this information is here, I go with init. Otherwise, I use start. And start is here at the top. It's just replacing the control so that you can insert your user, your room, and your information. So nothing fancy. When you have user, chat room, and language, here, I use the connection. So this is how you normally use WebSockets in the browser. You normally create a connection. So this is when I create a new WebSocket to that URL that was given. I don't have authentication for now, so that's easier. And then you can receive events from the WebSocket connection. So on open is when the connection is opened. So when a connection is opened is when the API gateway will send connect to the Lambda function, but it's not sending a lot of information. So what I do automatically, when the connection is created, I send a message where I send, this is the first message, so I call it this action init, and I say, this is my language, this is the room I want to be connected to. So action will be the route key that I use to process the messages in the API gateway. If there is an error, I just write the log. And this is the most important event, when there is a new message. So when the server is sending a new message to me, I analyze this message, I extract some information, and I display the new message that has appeared. So there's just a little bit of formatting to display, hey, this user posted this message on the chat room. This is the clean way to close a connection. And normally you can have timeouts. Like if you use this like you would use Slack, you can have like 10 windows to different rooms. It's very easy that you get timeouts or something. So what I do, and this is suggested normally with WebSockets, if the error code that you get is different than 1,000, and this is, let me just show you how this works in the specification here. So the close event here. So basically, there is, when a connection is closed, this is the standard that is described in the Mozilla website. 1,000 is normal closure. So this is the only case that you close a connection in a clear way. Everything different, 1,000 normally means there has been some kind of error. So what I do, in case of the error is different than 1,000, I just reconnect. So in this way, if you go back to the window, it will automatically reconnect. And this is just the send message. This is how you send messages to a connection. And what I do, I use JSON for, I have a JavaScript object for my message, and then I put everything into JSON before I send it to the connection. So this is really everything that is happening in the browser. So let's now have a look at the API gateway. So let's go on the AWS console here, and let's go on the API gateway. And here I have the positive chat WebSocket. And it's even easier to use than the traditional API gateway. So here you have the route keys. So this is connect. And this, in case of connection, I send everything to the, I'm using actually the same function for all the events, but you can use different function. So if there is, let me make it a little bit smaller because it's not readable. So if I have a connection, then I send to this positive chat function. If I have a disconnection, the same. If there's anything that is not defined, is sent again to this function. And here I could define route key. And the route key will look into the request body. So the request body is the message. And inside this message, as I said before, I'm using the action to say which is the action. So is this an action? Is this an initialization information or so on? So this is, in this case, I'm not really using, I'm sending everything to this function. And what this function is doing, if we go here, we can open the second part of my app is here. This is, I'm using here SAM, the serverless application model, to describe the application infrastructure at the end. And here I have my chat in the backend. It needs a DynamoDB table for connection. And by the way, if you use DynamoDB, you may have noticed that we launched what we call DynamoDB on demand at reInvent. That means that you don't need to set a provisioned throughput, and you only pay for the actual reads and writes from DynamoDB. So unless you have a very steady workload, it's normally much, much cheaper DynamoDB on demand. And this is how you specify to CloudFormation and SAM to create a table using paper request. As you can imagine, paper request was the internal name of this feature until 2 hours before the keynote. And so that's why it's still here. And then this is my connection table. I have my connection ID and the association with a room. And I create an index so that I can search by room. So the idea is that when you connect, you publish this connection ID is listed in this chat room. And then if I send a message to a chat room, I use the index to say, hey, what are all the connections connected to this chat room, so I need this index to do the lookup of the connection that needs to be notified. I have a conversation table where I store all the conversations. The topics table, I just created a table. It's empty, but the idea is to have a room, and then for each room, all the topics and some information of what's been written in that room. And this is the description of the function itself. So this is the Lambda function. The code is here in this positive chat directory. It's, again, Node.js, so JavaScript. And the interesting part here is lots of permissions, because this Lambda function must be able to interact with a lot of things. So first thing, I need to be able to post the messages back, so these managed connections. And here I was a little bit lazy, so there's lots of asterisks in this IAM policy. I know that I will be corrected probably in the next session. But you can be more defined here. So you can add the API ID and your account ID here. It's not complex, so you can be a little bit more secure here. Then DynamoDB, you can put an item, get an item, or delete an item from the connection table. And then with DynamoDB, you can have get item is to read by key. And then if you want to read using index, you use the query. So I need to be able to query using the room index. So when I want to know all the connection in a specific room. Here in the conversation table, I need to put and query. And then I have the topics table at the end to update and query items. At the end, I give permission for comprehend and translate. So to comprehend has different ways of analyzing text. I want to give access to detect dominant language. That basically is very powerful because it can detect, I think, more than 100 languages or something like that. So the idea is that any text you give, it will understand which is the dominant language there and can give you a list of all the languages if there's more than one, optionally. There's the detect sentiment. So what's the sentiment? And the detect entities. What are the entities? So the detect sentiment needs to know the language. That's why I need to do also the analytics on the language. So I need to know which is the language, because when I call detect sentiment, I need to say detect the sentiment of this sentence, and the language is English or German or Italian. And translate as translate text to translate text. In this case, the resource is always asterisk. So no, it's just because it doesn't make sense to have a resource. And then these tables that are created here by this template, I pass them to the Lambda function as environmental variables. So these environmental variables here will contain the name of the table that is automatically generated by CloudFormation and SAM. So this is the good pattern to pass information to a Lambda function that is being created. And there's some logging here. If we have a look at the code, so this is a little bit longer, but I want just to show you how easy it is. So I create 3 service objects from the AWS SDK. So the first is the DynamoDB document client. So if you use DynamoDB with the straight client, is annoying because you need to specify if every field is a string, is a number, or is something else. If you use the document client in JavaScript, it will automatically map JSON into the correct formats. So it's my suggestion to use the document client. And then I create a service object for comprehend and for translate. I keep the list of the supported languages here. I import the name of the tables that has been created. I also cache the translation, so it's currently just in the memory of the function, but I expect that lots of people will say, OK, what? So it doesn't make sense to pay for a translation or for analytics every time. So it probably makes sense to cache frequent short sentences so that it's be faster and cheaper to run. And then this is the Lambda handler that gets the event. And the event will be this message that has been sent using WebSockets. So here I have, in the event, there is a component that you get is the request context that tells you how this request is happening. So, and you get the event type. The event type will be connect, disconnect, or this is a message in the connection. So if it's connect, I don't do anything because I use the initialization message. If it's a disconnection, I delete the connection from the connections table. If it's a message, I process the message. And here I use this information to create an endpoint to post the messages back. So this is a little bit of a hack. So as I said before, if you want to send a message in a WebSocket channel, you need to do an HTTP post and sign this with the AWS SDK. It's something that you can do, but it's annoying. there's no real backend API to do that. It's just an HTTP post. So what we did is we created a fake API in the SDK that is called API Gateway Management. It's a completely fake API. There's no backend API. In fact, what you need to do is to use this, and then you need to change the endpoint of the API to be the domain name, that is basically the API ID, and the full path of the API gateway, and the stage of the API. In this way, when you use this service and there is a post to connect API, we will just do an HTTP post to this endpoint. So if we didn't do this hack, you would have to use our SDK every time to build 3-4 lines of code to do assign HTTP post. This is a little bit of a hack, but it makes things easier. And when there is a message, I go into the process message. And here I look into the action of so if the action is message, I analyze the message. If the message is rejected because the sentiment is negative, I reject the message. Otherwise, I send the message to the room, so to all the connections in the room. If this is the initialization message, I initialize the connection, storing the connection ID and the room and the language that I want. And then I send all the messages of the room to the user that is connected. Currently, I send everything. Probably if you have lots of messages, you should send only the last maybe 100 messages, and then you can scroll back. But currently, I didn't build any pagination on this API, so that's how it works. A little bit more interesting is the analyze message here. So the analyze message here, I use comprehend to detect the dominant language. And this is a way to use more advanced JavaScript features like await. So JavaScript is completely asynchronous, and that can be annoying when you don't need to be asynchronous. So our API, our SDK, you can transform any invocation into a promise in JavaScript. And then when you create a promise, you can say, wait for this promise to complete, and then you can make things much easier. So you need to build callbacks that can be complex when you don't need them. So I wait for comprehend to give me the dominant language. The dominant language, most of the times, is just a single language, but it can return a list of languages. So I use this trick here with reduce to get the language with the highest score. And then I check that the language is one of the supported one. If it's not supported, I say, no, sorry, this is not supported. And then if it's supported, I use detect sentiment. And then I get the sentiment data. And if the sentiment is negative, I send a message back in English saying, please find a better way to express this. Since I know this is English, and I know the language this was being sent, I translate this into the language that was used to send the message. So if you send a negative sentence in German, you will get this translated into German. It's not a challenge. And then I detect the entities. And I just do a little bit of wrapping up to have a list of topics out of this entities list. Final thing that I want to show you is when you send messages, there is this important trick that you need to use. Let me just send a message to connection. So this is the function that will post back to a connection ID a message. And as I said before, not all this connection will tell you that they disconnected, because if you have a timeout or if you just lose connectivity. So you need to check for the error here. And this is in the documentation. If you get this status code here for 410, that means that the connection is not existing anymore. So then you can delete the connection so that next time you will not try again to send the message disconnection. Otherwise, you would have a growing list of connections because they will stay there for some time. So this is something that you should always do when you use WebSockets, so manage this error. So lots of talks. Let's see if this works. So this is it's just a prototype. As I said before, I don't have, I think, front-end skills, but the minimum that I have, I didn't invest here. It was just the idea of having something very simple to understand. So there is no formatting in the HTML. Normally, I use Bootstrap or these kind of things. And if this image here will automatically send you to this room that will probably host a few people from here. So can I join the room? We want to have a little bit more time to. I see people taking picture of the QR code. I hope I tested it. So let's go here, and let's make this a little bit bigger. So I can choose my user. As I said, there is no authentication, so I use Danilo. It's my Twitter handle, and it's my email at amazon.com. The room is already populated, and let's use English so that everybody can listen here. And wow, there's lots of stuff already happening here. And let's say that I want to switch to Italian. I can change here in the URL the language to be Italian. And you see, grande chiacchierata. Buongiorno. You see, from any language, I see the source and the language. And for example, if I want to say something like, I really hated this session. Oh, it passed. So. No, this is probably a bug because it's sent by positive chat. So it was sent. So this is some last-minute change. So probably you shouldn't have seen that message. It's only for my own eyes because this should be the translation of that message. So last-minute changes that didn't work. And if you talk about something, you should also that. So I like presenting AWS stuff. It crashed? No, OK. And you see this is an example of it recognized that there is a topic in this message, so it put it there. It's fast. And it's not perfect, but it's just a first implementation. So that's what I wanted to show. So first of all, there's lots of technical possibility with WebSockets, and you can use serverless application to do cool stuff. And let's move to French. That is always more polite than other languages. It's now translating the hell. Yeah. OK, nice. There's lots of possibilities. And when you use social media, when you chat, you don't need this kind of tools, but always think the best way to express yourself. Thank you.
Thank you. Thank you very much, Danilo. We've got enough time for 2 questions. So who does have 1 question? Or maybe 0, I don't know. Any question? You sure?
So no question means that I was really clear in my explanation,
apparently.
or completely obscure that nobody has
maybe
a clue.
the questions are in the chat.
In which language? Oh, we have a question.
Yes.
Yes, yes. So I will publish that on GitHub, and when I will do that, I will share with the user group. It was still not mature enough, I would say, to share it. I was a little bit shy, probably. They said you shouldn't be, you always should be a little bit embarrassed because before releasing something, otherwise it's too late. But
cool.
Question there?
Yes.
Yes, I was just wondering, how long would you say that took you to develop and
So how long? Sorry.
Yeah, how long did it take to build?
To build this, so I did it. I would say in a few hours, the core was working, and then it takes 1 day to build something like that. It's more like managing the edge cases and doing mistakes like I did than the rest. It's, as you saw, I think what is cool with serverless is that the lines of code are fewer. And at the end, each line of code needs to be maintained.
Cool. Well, thank you, Danilo.
Thank you.